Look around you. Take a moment to see the world we've built. The smartphone in your pocket, the tablet on your desk, the giant screens in city squares. They all share a secret, a simple language that powers our entire digital existence. This language is built on just two words, on and off, or, as computer scientists like to call them, 1 and 0. Every game you play, every video you watch, and every message you send is just a fantastically long and complex sequence of these ones and zeros. It's a binary system, a world of black and white, yes or no. This simple foundation has allowed us to build incredible things and connect with each other across vast distances. These ones and zeros are stored in tiny switches called transistors. Think of them as microscopic light switches, billions of them packed onto a chip smaller than your fingernail. When a switch is on, it represents a 1. When it's off, it represents a 0. For decades, we have made these switches smaller and smaller, cramming more and more of them into every device. This is why your phone today is more powerful than the giant computers that sent humans to the moon. We have pushed this binary world to its limits, creating a symphony of logic from a simple 2-note song. It's a testament to human ingenuity. But what happens when we can't make the switches any smaller? We are approaching a physical limit, a wall where the rules of our everyday world start to break down. When things get incredibly small, on the scale of atoms, the universe begins to play by a different set of rules. These are the strange and wonderful rules of quantum mechanics. It's a realm where things can be in multiple places at once, and particles can be mysteriously linked across space. Our classical computers, with their simple on or off switches, are not equipped to navigate this bizarre new territory. To continue our journey of discovery, we need a new kind of computer. So, we stand at a crossroads, a pivotal moment in the history of technology. We have mastered the world of ones and zeros, the classical domain of information. We've built empires of data on this solid foundation. But the greatest challenges, the deepest mysteries of the universe, from creating miraculous new medicines to understanding the fabric of space-time itself, require a different approach. They require us to embrace the weirdness of the quantum world. We need to build a machine that speaks the universe's native language, a language that goes beyond simple yes or no. This is the dawn of quantum computing. Imagine a coin. In our classical world, when you flip it, it can land on either heads or tails. Our regular computers work like this, using bits that are either a 1, heads, or a 0, tails. It's a definite state. But now imagine that coin while it's spinning in the air. For that brief moment, it's not quite heads and it's not quite tails. It is a blur of both possibilities at the same time. This is the essence of a quantum bit, or a qubit. A qubit can be a 0, a 1, or a mind-bending combination of both simultaneously. This property is called superposition, and it's the first secret ingredient of quantum power. Now let's add another layer of quantum magic. Imagine you have two of these spinning coins, and they are magically linked. We call this phenomenon entanglement. If these two coins are entangled, the moment you look at one and see that it has landed on heads, you instantly know the other one, no matter how far away it is, has landed on tails. Albert Einstein famously called this spooky action at a distance. This connection between qubits is instantaneous and profound. It allows quantum computers to create complex relationships between bits of information in a way that classical computers simply cannot fathom. It's like having a team where every member knows what the others are doing without ever speaking. So how does this make a quantum computer so different? A regular computer with, say, 4 bits can only represent one combination of ones and zeros at a time, like 1011. It has to check every single possibility one by one, which can take a very long time for big problems. But a quantum computer with 4 qubits can hold all 16 possible combinations at once, thanks to superposition. It exists in a rich state of all possibilities, 0000, 0001, 0010, and so on, all at the same time. This ability to explore a vast landscape of solutions simultaneously gives it a monumental advantage for certain types of problems. This isn't just a faster version of the computer on your desk. It's a completely different way of thinking about and processing information. It's like comparing a bicycle to a spaceship. Both are forms of transportation, but one operates on principles that allow it to travel to entirely new worlds. A quantum computer doesn't just calculate, it explores a universe of possibilities. It operates on the fundamental principles of reality itself, harnessing the strange and beautiful dance of particles at the subatomic level to solve problems that would take a classical computer longer than the age of the universe to crack. Why do we need this incredible power? Because the universe is not written in ones and zeros. It's written in the language of quantum mechanics. Many of the world's most important and complex problems are, at their heart, quantum problems. Think about designing a new medicine. To do that, scientists need to understand exactly how a drug molecule will interact with the proteins in our bodies. A single molecule is a complex system of atoms and electrons, all obeying the laws of quantum physics. Simulating this behavior with a classical computer is almost impossible for anything but the simplest molecules. It's like trying to describe a symphony using only 2 notes. A quantum computer, on the other hand, is a natural fit for this kind of challenge. Because it operates using quantum principles, it can create a perfect digital twin of a molecule. It can simulate every possible interaction, every subtle twist and turn, with breathtaking accuracy. This means scientists could design and test new drugs for diseases like cancer or Alzheimer's right inside the computer, dramatically speeding up the discovery of new cures. They could find the perfect key to unlock a biological process without spending years in a lab. It would revolutionize medicine and could save countless lives by making drug discovery faster, cheaper, and more effective than ever before. Another area where quantum computers promise a revolution is in the creation of new materials. Imagine designing a superconductor that works at room temperature, which would allow for lossless energy transmission and hyper-efficient electronics. Or what about a new catalyst that can pull carbon dioxide directly out of the atmosphere, helping us fight climate change? These challenges involve understanding the quantum behavior of materials on an atomic level. A quantum computer could simulate thousands of potential atomic structures to find the one with the exact properties we need, a task far beyond the reach of today's supercomputers. It's like having a virtual laboratory where you can build and test materials atom by atom. This quantum advantage also extends to complex optimization problems. Imagine you are a delivery company trying to find the most efficient route for thousands of trucks visiting millions of destinations. The number of possible routes is astronomically large. A classical computer would get bogged down trying to check them all. But a quantum computer, using its ability to look at many possibilities at once, can find the optimal solution much faster. This could transform logistics, finance, and even weather forecasting by finding the best patterns in incredibly complex systems. It's not just about doing things faster. It's about finding answers to questions we previously thought were unanswerable. The journey into the quantum realm is just beginning, but the destination promises to reshape our world. The possibilities are as vast as the cosmos itself. In the field of cybersecurity, for example, today's encryption methods rely on problems that are too hard for classical computers to solve. But for a quantum computer, breaking these codes could be trivial. This sounds scary, but the same quantum principles can be used to create new, unhackable forms of communication. Quantum cryptography could secure our data with the very laws of physics, creating a future where our digital privacy is guaranteed. It's a new kind of arms race, a race to build a more secure world. Think about the future of artificial intelligence. Quantum machine learning could create AI that is far more powerful and intelligent than what we have today. It could analyze enormous data sets in new ways, finding subtle patterns that could lead to breakthroughs in everything from astronomy to economics. An AI powered by a quantum processor might be able to understand the universe on a deeper level, perhaps even helping us solve some of its greatest mysteries, like the nature of dark matter or the origin of life. We could be on the verge of creating a new partner in our quest for knowledge, a machine that thinks in the native language of reality. Of course, building these machines is an immense challenge. Qubits are incredibly fragile and sensitive to the slightest disturbance from their environment, like a tiny vibration or a change in temperature. Scientists and engineers around the world are working in state-of-the-art labs, pushing the boundaries of physics to build more stable and powerful quantum computers. It is a slow and difficult process, but every breakthrough brings us closer to unlocking this incredible potential. Just as the first electronic computers filled entire rooms, today's quantum computers are large, complex devices. But the pace of progress is accelerating. This is why learning about quantum technology is so important. You are part of the generation that will see this technology mature and change society. Understanding its basic principles is like learning the alphabet of the future. The quantum revolution will need creative thinkers, curious scientists, and bold engineers to imagine new applications and solve the challenges that lie ahead. The universe has revealed its strange and beautiful rules to us. Now, it is up to us to harness them, to build a future that is smarter, healthier, and more secure.